Is it recording, Beatrice?
We are recording.
All right, great, thank you. So good morning, everyone, and good afternoon to folks in Asia. So today we are on day 3, session 1 for the project Education for Technological Literacy and Inclusion. And what we did yesterday was more or less, Bakshish gave an idea of some concepts of machine learning, what is the general process, what are the kinds of algorithms or problems that we have. And towards the latter part of yesterday, we started with a classification case study. We didn't get through a lot of it, so we are going to continue from where we left off yesterday. But as per feedback received also, we will focus more on the content part. We won't go too much into the code and the Python syntax and everything, because that is just to get you familiar and, it's easy to explore on your own. I hope I'm clearly audible. Is it fine?
Yeah, you are perfectly audible.
Okay. So today we'll focus more on the content part and not too much specifics, but I'll give you some tips or some resources where you can, check for syntax or parameters whenever you need, right? Yeah, so let me share my screen. I know maybe some of you missed yesterday's session, so that's fine. What I'm going to share is basically the Jupyter notebook where we are executing our code. And if anyone needs help to access the notebooks, I can, connect with you one-on-one later and help you to navigate it from your Anaconda navigator, right? So is my screen visible to you?
Yes.
Okay, great.
Yes.
So, okay, perfect. So yesterday, like I said, we started with this classification problem, which is about identifying or predicting whether or not a customer is going to leave our services, right? Is going to churn. So it's a yes or no prediction, so to say, right? So hence it is a classification problem. And we ran with the cleaning part of it. The last thing that we did was we cleaned up some null values where we substituted with monthly charges. So we will start from here where we left off yesterday. If at any point you're not, yes.
Excuse me, Marlene. Maybe I will start by defining which is the dependent variable. That is the variable we want to predict, and which are the explanatory variables. Okay.
Oh yes,
in the model.
Sure.
Yes.
Sure. So
thank you.
Yes, thank you. So right now we have the dependent variable as churn. So churn is the variable which is telling us whether or not the customer is going to leave our services. So if I show you here, churn has unique values, yes or no, right? So that is our dependent variable, and all our other variables, whatever we have at the moment, they are our explanatory variables, so to say, right? And we have just reached the point of kind of segregating what are the categorical variables and what are numerical variables, and we'll go from there, right? So this is what we are trying to predict, churn, right? Everything else is, all of those are the explanatory variables, okay? So I am here just, making a list of my categorical variables. So whatever, yes or no, if it's senior citizen or not. Yeah.
If I may, can you explain just in a word which explanatory variables we have? Sorry for this.
Which variables? So at the moment we are going with all of these, but we will do some feature engineering also, and we'll add more variables. So
yes.
If you want to go straight to that, I can. So what I was thinking, Beatrice, is that the first session, the first 40 minutes, 45 minutes, I will finish this case study, and then in the next session, because the regression and clustering analysis, the data sets are very small, so it won't. There's no cleaning or anything required. So I could focus on just the modeling part for those, if that's okay.
Yes, this is perfect. No, just to say which variables we are using as independent variables, planetary variables, like gender, whether the age of the person, whether they are partners or not, what type of telephone they have, So as we are economists, we have the logic, okay? So we
Right.
need to make the logical economic connection between the explanatory variables and the dependent variable, just to measure it, nothing else.
Right, right. Yeah. So these are all my explanatory variables at the moment. These are only the categorical ones that I've taken, and churn is my explained variable. But I will, we will go later and see, okay, which are the significant ones, which are the ones that I'm actually going to include in the
Okay.
model. So right now, I'm not going to take all of these into the model. It's just to do a little bit more analysis with the variables and maybe get new features out of it, and then we'll see which are the best ones for the model specifically.
Perfect. That is very, very clear. Thank you.
Great. Okay, thank you. So here, like I said, I'm just taking a list of the categorical columns only for the sake of some visualization. So here I'm just, having a code to give me some pie charts, right? This is just interesting for you to, in terms of Python, that you can combine different things, right? Here I'm defining a function specific, and using that function, using a for loop, I'm also calling this function. So with just 2 lines of code, I'm able to print like, multiple pie charts. So this is just giving me a visual representation of the data, the composition of the data, right? So you see here, like, yeah, male, female, more or less same. Senior citizens are few, like we have few customers who are senior citizens. So just all the categorical variables, we have just visualized it just for observation's sake, right? And you can see various things, online security, what are the categories, what are the percentage of customers in each. So this is just for observation. If there's any inference that you can take of it intuitively, then we can, use it in our modeling also later on. And this is our final explained variable, or sorry, yeah. And here we
So
see
we
that,
can, yes.
yeah, sorry.
No, go on.
Okay. So here we see that it's a little bit biased in the sense that we have very few customers who have actually left, right? So churn is basically those who have left within the last month, so to say, right? And we will have to treat this also before we actually do the modeling part, because if we, because our data is biased in this case, so we will see how we can treat that also before we train our model, right? So that's just on the visual side. Similarly, I have done the same thing for a bar plot, So for the categorical variables, just to see, it's the same thing, just a different representation. I'm just giving you some options. And
Yes,
here,
maybe we can stop and analyze one of them, the graph,
okay,
one graph, just to have an idea. For instance, payment method,
payment method.
or that one, for instance, just to
Right.
have a look.
Yes. So in our code, we have specifically given a command called dot value counts. So it's just counting from the total data. It's just giving me how many data points are paying by like how many customers are paying by this, or by mail check, or by bank transfer, etc. Just the categories, right? And I have the ratio also. So the ratio was for the sake of the pie chart actually, and this is, yeah, just for you to see the composition. So, but eventually we'll see whether or not this is an actually significant variable or not, right? That is yet to be discovered, right?
Thank you. Thank you.
Okay. And here I have just combined, basically we are seeing out of each category in each of the in each of the subcategories, how many people are churning and how many not. So for example, here under gender, you see that, okay, these many females are still our customers and these many females have left. So an analysis of that sort. This also may or may not be useful. I found one interesting observation, perhaps, let's say, in internet service. Okay. So in internet service, you see there are three different types, three different values, that you have DSL or fiber optic or no internet service, right? And if you look at the plots, if you look at the bars, you see the proportion of people who don't have internet service and who have actually left is quite less. But who have internet service and fiber optic internet service, and a lot of people have left. No, this orange is the number of it shows the quantity of those who have left our services. And similarly for DSL also quite a few people have left. So maybe I don't know, maybe their internet service is not good, so those who are not availing that service have remained. No, so something like that we could just think intuitively, right? So yeah, we see similar things. It's easy to plot multiple things using the for loop and your defined function. So that's what I'm trying to also convey here. So I'm just skimming through these because, yeah. Okay, so that's more or less how we have and try to analyze our categorical variables at a high level. Now we look at our numerical variables, right, or our continuous variables, so to say. So we have monthly charges. That's the monthly expense for your plan, and your total charges, which is actually nothing but tenure into monthly charges. This tenure is in months in this particular data set, right? So here we have an option of doing a dot describe. If you remember, DF is just my whole data frame, the whole data set that I had from the beginning. So when you say dot describe, it will only calculate that the actually numerical values. It will do some analysis, so you can readily get the mean and the max and quartiles, everything, right? So with that also, we can do a short visual analysis where we see, okay, in this, for example, what I'm trying to show is the people with an average tenure of 37, 38 months, they are not leaving, right? And the people who have less average tenure, so they are new customers. So they are the ones who are leaving more, right? Like you can intuitively say. So I'm just skimming through these things because it's just the visualization part. Now here I am just using the dot core command to see the correlation matrix, right? So, and the same thing, you can also use a library called Seaborn. Seaborn we have abbreviated and we are calling that library SNS. So from that you can use the heat map functionality to see it like visually. If you had more variables, then it might make more sense. But here you see that, okay, clearly total charges and tenure are highly correlated because the longer you have been a customer, the more you have paid, right? Monthly charges and total charges, yeah, also there seems to be some amount of correlation. But tenure and monthly charges doesn't really look like there is any correlation because monthly charges is your base amount that you would anyways pay every month, right? Irrespective of whether you have been availing services for 1 month or 10 months, right? So that is how we can show this visually, the correlation matrix. Then here I am just again looking at the numerical variables in terms of a distribution plot, just for us to have an idea that like it's a simple command and this is the kind of result you would get, right? So you can see tenure, right, from 0 to 70 something. And so I have a high number of customers who are new relatively, right, who are between 0 and 5 months, so to say. And but I also have a quite a good number of customers who are loyal and have been around for quite some time, right? Um,
This is very interesting
yeah.
because it's giving the pattern of the
Right.
customer pattern here.
Yes, yes.
So thank you, Marlene.
No problem. Similarly, we can see here also in monthly charges, right? Yeah, so we have a large number of customers who are availing plans which are of less cost, so to say, right? And many people are in the medium, so, and very few people are availing plans or subscriptions which are very expensive on a monthly basis. And if we look at total charges, so yeah, it's just we have a lot of new customers, so their total charges is quite close to zero because maybe they've been around for hardly a month. And yeah, right, so this is just for our understanding. And you can also do scatter plots by, from the same library, from Seaborn library. You can just give your X and Y variable. So tenure versus total charges, we already saw in the correlation matrix also that they are quite related, and so the longer that they have been with our service, the more their total charge will be, right? And monthly charges versus tenure, well, there is not any kind of correlation as you can see from the data itself. And monthly charges versus total charges, yeah, I mean, if you have high monthly charges and if you have been around for a long time, then you have high total charges also. But you can also have, this whole line at the bottom, more or less, these are the people who have like recently joined our services. So they have a low total charge, but the monthly charge is something fixed. So then we have people of different subscriptions, so to say, right? Okay. I hope it is okay till here.
This is perfect.
Okay. Oh, thank you. So now we move on to outlier analysis, and I'm sure all of you remember even from the June seminar that I think Beatrice had mentioned about, I mean, that we need to be careful with the outliers because they can skew our analysis, right? So for that, we have different ways. So here I'm just trying the visual way with a box plot. And yeah, so this is how you can, again, I'm using a for loop, and for all my numerical columns, I'm doing a box plot simultaneously, right? So with 2 lines of code, you can get 3 different box plots. But in this case, we don't actually have any outliers as such. So this is our third quartile, and this is our median. So if we had any points above this or below this, right, then we would have to treat them. But in this case, the data is looking okay, and we don't have to, look out for the, treat the outliers. But in case if you do have to, then I've just put some code here in comments. Like you can use something called as the z-score, which is from the SciPy library. And we will see also the library, the documentation in some time. So if you use the z-score, then you can also, if you want, you can remove the outliers from the data, right? So wherever the z-score is less than 3, I will keep only that part of the data and I will discard the remaining if you want to do that way. Or also you can, maybe apply a cap value, right? So if some value is going beyond a certain threshold, or if it's going below a certain threshold, then you can cap it at whichever point you wish, right? So just some options to treat the outliers, right? And okay, so here we have,
Very nice.
yeah, thanks.
Very
So
nice.
good. I hope so. This is also available in the notebook that I've shared with you. So in comments, you can use it. Like you can search for this particular library also to explore more parameters. So finally, I am just doing this one last thing to set my explained or dependent variable just to replace the yes with 1 and the no with 0. And like Jency and Bakshish have already said that our machine is only going to understand the numbers. So we start, that is the next part. We're going to start and converting everything into a numeric format, right? So yeah, this is, and if you notice here, I'm using in place equal to true. So it's just kind of like a permanent change, right? So now if I look at my churn column, I will only have ones and zeros, right? Okay. So now we are going into a part which is known as feature engineering, but it's not as complicated as it sounds. It's just to derive some new features, if anything, apart from the things that you have, or if you can combine two, three features and make a better one. So ideas like that, right? So here, one thing that is done is the tenure that we have, right? The number of months. Instead of having like from like we have starting from 0 months, which is basically the new customer, till around 72 months. So instead of having that kind of a value, we can convert it into a categorical variable, and here I am doing that. So basically, if a customer has been with us for less than 12 months, right, between 0 to 12 months, then I'm categorizing that person as 0 to 1 year, and similarly 1 to 2, yeah, all these categories, right? And I'm creating a new column called as tenure underscore year, and in that column we will have these kind of values. So here we are just again doing dot head just to see, okay, how is our data looking at the moment. And you can see here my churn is 0 in terms of 0 and 1, like we already converted. And I have a new column, tenure year, right? So, and these are the different values that are there. Then we have other features that we can add. Okay, this is like you can also explore it later. I'm not going into much detail, but just a few things that are combined. So, for example, engage. So, this new is just to notify that these are new variables that we have introduced into our analysis, right? So, engaged as in if our contract, if the contract of the customer is of 1 year or 2 year, then we can call that customer as someone who is well engaged in our services. So for that, I will give a 1, if not 0, right? So already we have converted this into a numeric format, right? Something that the machine will understand. Similarly, you can use other columns. So online backup. If they do not have, if you remember, this exclamation equal to means not equal to, right? So if there is no online backup, if there is no device protection, if there is no tech support, then I am saying that this customer does not have protection or backup, and it will be 1, right? Otherwise, the value will be 0. And similarly for other, other features, right? If there's any streaming service that has been availed, right? So if there is TV streaming and if there is movie streaming, then yes, otherwise it's going to be a 0, right? So just we are creating some flags and some new features. Here we are also creating a couple of new numeric features. So we need to be careful sometimes when we do divisions, in case if there can be the 0 value in the denominator, then it will throw us errors, right? So that's why here I've used a dot where, means that I'm giving a condition. So if my tenure is not equal to 0, then just give me the average, right, the total charges by tenure. But if it is 0, whatever is coming after the comma will be the output. If it is 0, then I will do total charges by tenure plus 1, right, just to avoid getting errors, right? So similarly, there's another feature here, right? And then I am just looking at my data again. So now we have all these new features, right? Tenure year and all of these in terms of 1 and 0, except for total services, which is basically the number of services that the customer has availed. So, and we have all of these are in zeros and ones, and these are other continuous numeric variables. Okay, so now another important thing to do is whatever categorical variables that we are still left with, we have to convert them into numeric also, right? For that, we use this functionality called get dummies under pandas. PD is I'm calling the pandas library here. Right? So get dummies is basically going to convert my variables into my categorical variables into a numeric form. So I am just going to show you an Excel for reference, right? We won't spend too much time, just to get an idea. For example, if I consider my internet service column, I have these different types, right? DSL, fiber optic, or someone who does not have internet service. So when I do a get dummies, this column will get converted or will generate three different columns, one for each of these values, right? So I will have underscore DSL, underscore fiber optic, underscore no, right? So wherever it is DSL, it will give me values of 1, and wherever it is not DSL, zeros, right? Similarly here, if it is fiber optic, then 1, otherwise 0, right? And similarly for this. So that way we have converted this categorical variable into a numeric format with three additional columns. But there's also the concept of a dummy variable trap, which is just to say that, okay, in this case, I have three different values. I can derive this column E from C and D. I don't need the column E, right? So I know that, for example, if yeah, if it is if he's already using DSL internet service, and if this is 0, then obviously this also will be 0 because he is having some kind of internet, right? Or if I can give you a better example, um, yeah, like if you say he does not have DSL internet service, does not have fiber optic, then the logical third column value will be 1, saying that he does not have internet service, right? So any one of the three from one any one of the two, you can derive the third, right? So to avoid that correlation between the variables, we will keep only any two of these three, right? So that is already built in the function. So that's why you see here, I do get dummies, and we already have an option of drop first equal to true, which means it's going to drop the first column, right? So I will not have this column. I will only have column D and D into my analysis, right? And it is, you can see that here if I do the dot head, right? So now all my dummy variables are created, and you see here that, okay, internet service underscore fiber optic and the other option, but I don't have the internet service underscore DSL column, right? Similarly, all the other categorical variables have been converted into ones and zeros, right? So then we do have a jump in the number of columns, right? So that's why we will again go and see which are the significant ones that we want to carry forward. So, okay, here I'm just listing down all the columns that I have now, and yeah, and all the types, the data types. I have renamed my new data frame as df underscore dummy, and I'm seeing all the data types. So now we are more or less good to go. We have all integer or numeric values here, right? Now we start to see the correlations with our uh, explained variable or our target variable, right? Is it okay till here? Is it too fast or?
No,
Uh,
no,
okay. Okay, great.
it is
So,
okay. We understand it because it is statistics and econometrics. You are focusing through Python, but we understand the statistics and econometrics under this. Thank
oh,
you, Merlin.
great. Thank you. Thanks. So here we are finally looking at the correlations of all of our variables with the target variable, right? Or the dependent variable, so to say. And yeah, so it's just for us to, maybe we can make some observations. My statistics and economics is not that strong, so Beatrice, feel free to intervene at any time if you want to add something or make some observations. Feel free to add, okay? So, but I mean, here you can see more or less like those who, if someone is a new customer, right, then there's higher chances. So the less engaged they are, the higher the chance of churn. Or you can make some inferences like that, right? But using this core with function, we are able to get this whole table in one go. Okay. and here I'm just sorting the values in the descending order and displaying it as a data frame. Okay. And one last time I'm checking if I have any null values, and I don't have any null values, so we are good to go. And now we come to this part called feature selection. So this is where I said that, yeah, we need to check which are our significant variables. And for that, we are going to use this sklearn library or scikit-learn. And we have this module feature selection from which you can import these functionalities, select k-best or chi-square, and there are many more. So I'll show you the documentation also. If you want, I can show you right away. Okay, now maybe. Okay, I'll show you later. Yeah, we'll go in detail into the library. And also, I'm making a new list of the categorical variables that I have, including the new features. Right now, here is the part where we are going to use the select k-best function and score using chi-square. Okay, we will fit the features against the target. So features are your explanatory variables. In this case, it's only for the categorical variables, right? These are your explanatory variables and your churn. So I'm taking just churn as my dependent variable, and that's what we call target. Right, so we are going to fit our features to the target and see, okay, what are the chi-square values, what are the p-values that we get. So this has the functionality of once you have these attributes, so you can get the scores, you can get the p-values, and you can make your data frame out of that. So I can get it into this format where I see the chi-squared score and the p-values, and you can just sort it in your descending order, or here I have sorted it in ascending order of according to p-value, and this is what we get. So from a simple concept, yeah, you have so many variables which look significant. Their p-values are less than 0.05, and except for the last few, right? Here you have higher p-values. And the same thing you can also
So, excuse me.
Yeah.
So this means that you are not going to include the last ones. Is it correct?
Yes, correct. I will drop
And as explanatory variables.
Right, correct.
Yes.
So this same thing we can also see in terms of a heat map, just color coded, right? Now before I drop the insignificant ones, we'll also do the same thing for our numerical continuous variables. So again, I'm calling my features and target, and here I'm going to get the ANOVA score and the p-value. So again, I can use the same attributes, score, p-values. The only thing I've changed in the code is that here in the score function where we define it, instead of chi-square, I'm putting f underscore classes, right? And then we get our scores here. So again, except for the last one, all the others appear to be significant, right? So I will just take a minute to show you this library so that it will be easier to see what are the options available, right? So the best thing is always to go to the official documentation of Python. So it's usually the first thing that comes also, right? So this is the whole documentation of scikit-learn alone. And here you can always find all the parameters that you have. So under select k-best, these are the parameters that you have, and you can modify it. So score function, it will tell you what all values can there be and what is the kind of output it is going to give, right? and what are the attributes. So from that I can get the scores, I can get the p-values, I can get n features, etc. And inside that, they have again defined all of the various functions that can be used. So this is just for reference, and there'll be some examples also, and the methods. Like, yeah, there's a lot of content available in the official documentation of each of the libraries, right? So this is always a good place to refer to. So going back to the notebook. Okay, so now I am going to make a choice of the variables. So here for the categorical columns, I am dropping the last 12 in that table, if you remember. So the last 12, because we have also quite a few. So these will get removed plus a few more, right? Basically the last 12 variables I'm removing from the analysis. And for the numerical features, I am going to remove this one for sure. And I'm also removing total charges because it is highly correlated with a tenure, right? So if you have monthly charges and tenure, you're already good, right? The machine can itself derive total charges from it. If so, we don't want correlated variables. So I am removing those two. So categorical, I'm removing the last 12, and for numerical, I am removing this new increase and this total charges column. So this is where I'm dropping them from my main data frame, and I finally have all the variables in place, my independent variables, right? Now, like I said in the beginning, this particular data set is skewed. So, I mean, it's biased, sorry, it's biased. The number of people who have churned is quite less, like around 25% only. So, and we don't want that to negatively affect our model. So we have to, bring back the balance. And for that, we have something called IMB Learn. So this particular module is not, some things are already automatically inbuilt in your Jupyter notebooks when you have installed it. Some things might not be available. So this one was not available and I had to install it. So it's a simple command. You just type this and you run it. It will install this particular module or library, right? And the installation commands also are always available online, right? You can use this one or this one, either works. So finally, from there, I'm going to use a technique called SMOT. SMOT is to generate more samples to, balance the data set. So if you want, I think it's better I show you in the library itself, right? So we have, again, different parameters. I am also not very aware of all the details, but yeah, they always mention, whatever. If you want to parameterize anything, you can, right? If you know more about it, then you can make things specific. But this is just going to create a balanced data set for me in this case. So I am applying that. This is not important. Yeah, here I'm applying the SMOT functionality, and that will make sure that I have a balanced data set. So it's just adding random samples to the data, right? So now I have the equal number of people who have churned and who have no, not churned, right? So now it's balanced, and hence my data set also, the number of rows have increased. Now we have 10,000 something rows.
10,000, sorry?
The number of
That's,
the number
yeah,
of yeah.
yeah, lovely.
So
Thank you.
because we had 7,000 in the beginning, but then
Yeah.
by this mode we have added some random data points to the set so that we have a balanced churn, right? Churn ratio. So then we see that, okay, the total number of data points has also increased, and it's just like 50-50 distribution, right? So now we are in good shape to go to the modeling, and this will be the last part for the first session of today. So sklearn is where you can import all your different algorithms from, right? And we have different kinds. You can use a logistic regression or k-neighbors classifier, decision tree, random forest, or XGBoost. Okay, and again, XGBoost was not automatically available, so I had to install it, right? These are the different algorithms, and there are more you can use. So what we are going to do is we will iterate over all of them and just see which is going to give me the best result, right? So these are the different classifiers that you can use. Decision tree, random forest is also tree based, so to say. So it's more like a branching out, right? So for a data point, there'll be one question, okay, does this person use internet or not? Then based on that response, there'll be a second question, and so on and so forth. And at the end of the tree, you kind of get the result. Okay, is this person going to churn or not? So I don't know if that was clear enough, but it's just a tree-based method, you can say, right? Yeah, based on decision trees. No, so and logistic regression is like, yeah, it's based on this S-shaped curve, you can say. I can show you in the library, in the documentation also, if you'd like to see in visual, right? So I finally have my target variable and my features, and I am just making a list of all the models that I want to use, want to try. Now here we see that, okay, I am sure Bakshish also had explained that whenever you have a data set, you have to split it. Some part of the data or the major portion of the data goes into training, and some part is for testing, right? So the training data will be determined from here. So you're using this functionality called train test split. You can give your ratio whatever you want. So in this case, 80% of the data will be considered as training data, right? And here I am also using something known as cross validation. It is just that so according to the number of folds that you give, it will iterate over the test site. So for example, if this was, let's say if this was 5, okay, so I will have a 5-fold cross validation. So the first time, maybe the first 20% of the data is my test data, and the remaining is train. Then in the second fold, the next 20% will be considered test data, and all the remaining will be train data. So it's just kind of iterating over it, and it just helps to get the best output. So that's why we are using the cross validation results and taking the mean output of all the folds, right, to see which is the best training best model, right? So here, this is again, everything is inside a loop. Okay, so it's looking big because all these things are going to happen for each and every one of these models, right? So it is going to loop through each of the model in my models list. So this is my models list, right? And once I run this, I get this result. So, okay, before that, this part is basically where I'm going to see how is it performing on my test data, right? So here I have trained my model on the majority part, on the 80% of the data. And now I have to test, is my model working? Is it able to correctly predict the output? So I'm using the dot predict, and I'm going to predict for X test. So X test is basically all the features, all the explanatory variables, but just for that 20% of the data, that is our test data, right? And from that, you can get the confusion matrix, which is just comparing our predictions with our actual, with our true values. So this is just going to show you the true negatives, the false positives, false negative, true positive. I think Bakshish also had explained this yesterday. And you can also plot your ROC curve using this functionality. So at the end, I get, for each of the models that I have applied here, logistic regression, k-neighbors, XGBoost, I can get the results here, right? So for logistic regression, okay, I see my accuracy 0.76. So here is the confusion matrix, which is going to say, yeah, 767 people were correctly predicted as true negative, so they have not churned, right? And 832 people have churned. So these are our wrong outputs or wrongly predicted outcomes, right? And you see the ROC curve, so and the area under the curve also will be calculated. And yeah, so for each of the models you can see, I think it would have been easier if I made a table of all the ones, then you can compare the values. But generally, yeah, XGBoost always tends to perform well, XGBoost and Random Forest. So here you can see that the AUC is also much higher. Even for XGBoost, it's higher than the other models, right? So, and these two are tree-based algorithms. And yeah, I think that is what I wanted to explain. Mm, we can also compare further, like sometimes what those who know, like I mean, those who know much in detail, you can add different kinds of parameters here. Okay, uh, if you look at your library, right? If I go to classification, right, this is the these are all the kinds of details that you can get. So we were, you know, if you go to each of them, for example, yeah, I was, let's see, ensemble gradient boosting, right? So if I look for one of these, I was just looking for the place where you see all the parameters. Okay, this is not where you see that. But yeah, what I'm trying to say is that in this, I have not mentioned anything here in the brackets, right? But you have a bunch of parameters. You can, give a specific learning rate. All the parameters can be defined if you prefer. So it's called as hyperparameter tuning, right? So the more you tune, the better it is actually. But in this case, I have just kept it empty. From the libraries, I mean from the documentation, you'll be able to see all the details, all the parameters that are available, right? Okay, I think that's what I wanted to cover for classification. Is it?
Excuse me,
Yes.
if I may.
Yes.
Can we go back to the results, please?
Yes.
Okay, so my first question is, as far as I understood, we are selecting one or two models from here. Is that correct?
Yeah, so we can select
So
one model. Yeah.
which one are we the most accurate one, or which is the criteria we will use to choose one model?
So yeah, usually you go by accuracy, but it depends also case by case. Like I think it depends on the particular business problem. Sometimes you need to focus more on precision. So if all of them are on a high stand, then it's fine. But some cases you might get that the accuracy is high, but the precision is low. So then we might have to look for another model. So in this case, I would go for either XGBoost or Random Forest because they seem to have the best metrics. But
Okay, so and then once you have the model, how do you get to know the influence of each explanatory variable on the dependent variable, if I may?
So the influence is only this part that where we already see the in terms of the significance, right? Now, once you've
Yeah.
already built the model, you can apply the same model. Now you don't need to train any data anymore. You can just use the model itself and fit for any data set that you get, any new data you get, and you can just use that, and then it will give you the you can predict. But it's true.
So excuse me, Merlin. So we are talking about prediction. Is it correct?
Yes, we are predicting. We are predicting the outcomes for the test data
So
here.
Okay, so we are our problem here is that we have some you call them features, we call them explanatory variables.
Right.
You have a target variable, we call it explain variable, and then we need to forecast what is going to happen in the future. And then you are choosing the best model. Is that correct?
Yes. So in this
Yes.
case, for forecast, it's only two values that either of two values can be the outcome, right? Only 1 or 0, since it's a classification problem. So
Okay.
that is what it will predict. But what you asked about the significance, I mean, how you see the influence of the variables in random forest and in some other models, you have an option of, after you train the model, you have a feature called feature importance. So there is a possibility to see also like a bar chart where you see which are the most influential features. So I have not plotted it here, but there is a functionality like that if you want to see also which are the most influential independent variables affecting the churn.
Thank you, Merlin. The concepts are very clear for us because we can see the statistics and econometrics which is behind this. So thank you so much, Merlin.
Thanks to you. So I think for classification, I hope we are good. Maybe we can take a break and then continue with the other case studies if that works, or if there are any other questions, or if anyone needs help in opening the Jupyter notebook also, I'll be available if anything.
Yes, I think we can have a 10 minutes break if there's no question. Okay. Merlin?
I think let's have a break and we'll continue later with another case study. Okay?
So thank you so much, Merlin.
Thank you. Thank you.
See you in 10 minutes. Bye-bye. Bye-bye. I'm stopping the recording.